So what is the limit? First thing I want to do is we're going to jump onto our Desmos friends, and we're just going to graph that particular function that's there. And let's see what it looks like. And let's see if we can decipher kind of just by what they have. Get divided by, and I have x squared minus 2x minus 3. And then that's going to be over x minus 3. Okay. So, any ideas why this particular equation just comes out to a straight line? I mean, x squared is a parabola, right? What do you think?
Maybe because you're dividing it by an x, then it cancels out.
It could be. You're close. You're close. So if you factored out the top would factor to x minus 3, x plus 1. And being they have x minus 3 on top and bottom, that means that 3 at exactly 3, so 1, 2, 3, notice at exactly 3, what is it? Undefined. So what's that called? It's a hole. Okay? I'm sorry that I can't get that hole to stay there, but you realize right there at that exact point, we have a hole.
And you do confirm it does come to things.
It should, because it kind of confuses the computer algorithm. Okay, it kind of starts looking like an EKG. Yeah. Okay, but a hole, basically, all a hole really is if I were to draw that line, I'd draw the line, I'd pick my pen or pencil up, skip over that point, and continue drawing it. Does that make sense? So what's going to happen at that hole, let's see if I can do this. Okay. I'm just going to see if I can find that hole, 3, 4. There it is. Okay. So that purple dot I have up there represents our hole. Okay. You okay with this? Now, what a limit is basically I'm going to come from one direction or the other, and we're going to talk about how that works in a moment. But I'm going to come from one direction or the other, and where am I trying to get but I would never get to? Okay? So if I just pick that, that's where our hole exists. So if I'm writing this line up, meaning I'm coming along in the x direction, I'm writing this up, and I'm going to get to here. And it's like, I got to stop because there's a hole. It's like a black hole. It goes forever. Or if I'm coming on the x-axis from this way, so it's coming down this line. So notice as these two lines are starting to come together, okay, and I know it kind of seems weird because, like, well, stirrup is a straight line. Yeah, it appears as a straight line, but the straight line, when you're talking about the red, is truly, it's truly undefined right there. Okay? So our limit as x approaches 3, because 3 is where the hole exists, my limit is 4. Okay? So I'm approaching it from either side. If I could ride this, if I could climb that slope, or I could come sliding down that slope, I mean, let's face it, if you've ever skied or snowboarded, you hit a hole, you kind of know that you hit a hole, right? Yeah. Or there's a hidden rock, you know you hit that hidden rock. And so our limit on this particular problem, as we approach 3, because 3 on our original equation, 3 minus 3 gives us a 0 in the denominator. A 0 in the denominator can't exist. So we are saying, what am I approaching? How am I getting to it? And so if I go back, just drawing an XY axis, and I have my line drawn, 2, 3. 1, 2, 3. Okay. This is our whole. So if in this equation, if they were to say the given equation is this, and they said, what would the limit of f at x be? And I'm going to explain this in easier terms. Okay? We have to realize that f at x is the same thing as y. Okay, so this is what's going on in the vertical direction. So as I'm coming up this line this way, so I'm just riding up this line right to here, or I ride down this line this way. As I approach to get to the x value of 3, the y value is going to be at 4. That doesn't mean 4 exists. It just means that that's our limit, that we can get very infinitely close to it from either side. Does that make sense? And basically why, again, this whole takes place is if you factored out this top, it's going to look like this. And being I have the same binomial on top and on bottom, this produces the whole.
So, and why 4 rather than 3? You have to find the matching thing and then that's the other side.
So the 3 is what's going on in the x direction.
Yeah. So it would be
The
4 is the answer?
No, the limit as we approach. So this is what the problem will look like, just like this. This says, if I'm traveling on in the x direction, and this one doesn't have a sign to it, so that just basically means I'm coming from both ways. What do I kind of get really sort of close to in the y direction? And I get really, really close to 4. Okay, so your 4, the y direction is dictating where your limit's going to take place. Okay, that's our first opportunity. Do you feel comfortable with that?
Yeah.
Okay. Let's take a look at the second equation, and I'm not gonna use Desmos on this one. So they're saying g at x. G at x is a fancy way of writing y, and they say x squared, and they also say 1. And up top they say that x is not equal to 2, and on bottom x is equal to 2. Okay, so let's draw what these would look like on our graph. I don't have my graph up, so I'm sorry. I let y'all down. Okay, so if I drew this, and all I'm doing is just pattern graphing. So this is a parabola. And they're going to say x is not equal to 2. So this right here is our whole for the top one, okay? Because we're not including that point, okay? If I say, what does this equation look like? This is a horizontal line that goes through here. And they said that 2 can exist here. This does, I'll just put a dot here, solid dot. That point does exist, but the point above doesn't. Okay. So do you all feel comfortable? There's 2 equations that are drawn up there. We have the blue and the red. We have the horizontal line and we have the parabola. Yeah. Oops. So y equals x squared and y equals 1. That's basically what's taking place. And then, so I'm going to just show on the table. So that black dot right there is where we're not going to exist with this graph. Okay. So, question for you. Yeah.
Why do we have the y equals 1 at all? Because isn't that just useless?
No, it's just a second function drawn. It's just two equations on there. Okay. So let me ask you this. If we are cruising along the blue line and we get to the point 2 comma 1, that dot exists on that blue line. We're allowed to have that exist. Okay? But if I'm cruising along the blue line, what is my y value if I'm on my blue line, if I'm cruising along it approaching 2? What does my y value have to be? Just look at the blue. 1. Okay? Doesn't matter if I come from the left on the blue line or the right on the blue line. Do I still get the same spot? Okay, if I am on the red parabola, if I'm going up, so you got to follow my cursor. If I'm going up the line, I get to that point. If I come down the line, I get to that point. So this point right here on the red is a different y value. Okay, so does this limit exist? Because they're saying as the limit approaches 2, does it exist? I don't know. What do you think? So if I'm on the blue line and I come across, I get to 2 comma 1. If I'm on the red line coming from the top or from the bottom to that point, I get to 2 comma 4. So whichever path I'm on, I get to 2 different y values. So does the limit exist? The limit can only be one number, one y value. How many y values are up there? 2. So this limit doesn't exist. Okay? So the next one, and I'll just do a couple of these and we'll finish them up tomorrow. Tomorrow's Thursday, right? These 3-day school weeks for you guys. Oh, we're working so hard. Don't get me wrong. I would have rather have been teaching y'all yesterday than sitting in and listening to, well, in my classroom, I do this and this and this and this. It's like, great. Yeah, and I find that students do this. Okay. I didn't like listening to it. I mean, it's fine. People should be excited about what they do.
How many learning labs have you had? With the learning labs thing, or all the teachers island over and stare at you, or like
Kind of. I mean, there was a handful of people calling, and this is what I do. I was recognized because I record all my lessons. So it's like, oh yeah, Chris Stirrup, he records his lessons like he's an idiot. Yeah, who said that? Stirrup did. Oh. I'm trying to mimic this picture. Okay, so let's see if we can. This looks like this is the 0.7 comma 2. This looks like it would be about the 0.7 comma 4. This looks like it's at about 5 comma 4. This point up here looks like it's 3 comma 6. This point I believe is 3 comma 3. Okay. So the first thing they say is the limit of g at x. So both of these equations represent g at x. as x approaches 5, and then it has a negative, it's like 5 raised to the negative 5, or 5 raised to the negative power. Okay, so let's take a look what this means. That raised to the negative means I'm coming from the negative direction. So on my board, I'm on the negative direction. Agree? So what I want to do is I want to try and get to this 5. So 5 is roughly here. So as I'm cruising along, I mean, basically this comes up, it just jumps up, and then starts cruising down. Where does this limit appear to be? It's part of the answer. 4. Exactly. It should be 4. I mean, I'm not going to have it as a bit on a really bad drawn graph. Okay, so this one, this means come from left, go left to right, and where do you get? In this case, you're going to get to 4. Okay, so that was basically this. Stop. Okay, that's where we came from. Okay. The next one says the limit as x approaches 7 from the negative side of g at x. Okay, so I'm going to get to 7. So we're cruising along right here. And where does this arrow point to roughly? It's the y value of that point. What's the y value? It's also 4. Okay.
Oh, but wouldn't it not be 4 because of their?
It is 4. Though you can accept the whole.
But there's underneath of it. There's a.
Oh, there is.
So what is
And that's going to mean something in a minute.
Oh, later because it would be 7. Like this
Mm-hmm. Okay. So let's change colors. Let's go to oh, that's a fun pink color. I like that one. All right, then we're going to say, all right, the limit as x approaches 3 from the negative side. So going left to right of g at x. So I'm coming right here. Where does that pink line wind up? So what is that point? What's the y value? Just on the pink. Notice I didn't jump anywhere. 3.
Isn't it like not a hole?
It's okay. It's just where are we getting to? So think about a hole. That bucket right there is a hole. Right there in the middle of my desk. I can get really, really close to that bucket. Eventually, if I get too close, I fall in, which kind of looks funny when syrup falls in a little pink bucket. But that's basically what the idea of the hole is. But let's say that hole we've just filled in with dirt. I can get really close to it and I can get to it. But I'm just a limit. I'm approaching it. What am I approaching? What am I getting? As close, infinitely close. The smallest little decimal you could think about, closeness factor. That's what I'm getting to. And the left, coming from the negative, coming from the left means something on these first couple of problems. Okay? So now let's change gears a little bit. I'm going to change colors. All right, so I'm going to do the limit as x approaches 5 from the positive side of g at x. So now I have this positive right here. So that means I'm coming from the left or coming from the right. Okay, so I'm looking at 5. So I'm coming right here. Where is this purple point that I just did getting to? What's the y value that that point is pointing to? 4. I need to get fancier with my colors. More. Ooh, that's kind of a fun one. All right. So let's do the limit as x approaches 7 on the positive side of g at x. So 7, I'm coming this way. Where is this arrow pointing to? 4. Okay. Dark purple. So the limit, ooh, sorry about that. Hopefully you could decipher the difference in purplish colors. So the limit coming from the right, going to 3. So I'm coming this way now. Where is this one pointing to? 6. Now we're going to throw a wrench in the game. So do this one in black, and then I will highlight it. Limit as x approaches 5. It's not raised to any negative or positive value. Okay? So what this is going to mean, I'm going to just do this in yellow. So I'm going to go to 5. Okay, so 5. Where's 5? Limit as I approach 5. Oh, okay. So it's coming this way, and it's coming this way. Where do those 2 yellow arrows pointing to? Let's do this one. Limit as x approaches 7. So this means I'm coming from both sides. Approaches 7. So let's highlight this. So 7 is here. Now I'm highlighting that dot. That dot is at 7. Okay? Those 2 pink ones, if that dot down at 7.2 wasn't there, it's going to give us an answer of 4. But this basically means, hey, I'm approaching 7 in the x direction. So on my graph, I'm here, and when I get exactly to that point, if I look down below, because I came from both sides, it goes from the point 7.4, which is a hole, to the point 7.2. So this one does not exist. DNA. Okay, because we have that point, that other point. 7,4 is indeed a hole. If I was just traveling along my 2 graphs, I would get to 7,4, so 4 would be my limit. But the 7,2 dot down below threw a wrench in the game, because as I come from the left, as I come from the right, I'm approaching. As I get exactly to 7, I get the point 2. 7,2. So this means I don't have a limit. If the limit exists, it has to be going from each side, it has to converge at the same point. If it doesn't, because you have a arbitrary point that throws it exactly in there for you, that means the limit won't exist. And then let's see, red. Let's do this one. So the limit as x approaches 3 of g at x. So again, this one doesn't have a plus or minus on it. Highlighter, orange. So do this one in orange. Okay, so as I go to 3, come up this way, I come up this way. Are the arrows pointing to the exact same y value? Are those orange arrows pointing to the exact same y value? No. This is another does not exist. Actually, I need to go back. I'm going to change this from DNE. When the limit approaches from both sides, it actually just comes out to be 2 because that is the actual point. Okay, so they change a little bit as you go. Okay, so what's really the best way that you can go through these? So what I'm going to do is, I'm not done with the notes, but what I would like you to try for next time is the page after this. You basically have this graph where you have this. Something like this. You agree? Kind of looks like that. I don't know. Something like that. So try 1 through 6. Okay. Now I will warn you that when it says f at -8, f at -8, go to -8 and you find the exact point. So this one would actually come out to be -3. Can I borrow your pencil for a minute? Thanks. Today is 2/22, and we're going to look at 1 through 6. Thank you. And I'm done recording.